To spend the next several minutes talking about how we move forward in applying marine technology. And what I'd like to do is break this talk into the pull of technology from sectors such as existing applications and how marine technology will make those applications better, cheaper, faster. But I also want to talk about the pull in terms of new applications, something many of us now call the new blue economy. And I'm especially pleased to follow Director General Howe because I think you will see that many of these concepts are consistent with the concept of prosperity from the ocean, as we just discussed. So let's talk about the pull from traditional sectors, if you will. And the traditional sectors include things like oil and gas. And I would imagine very few in the audience need to be convinced that it's because of the work in oil and gas that new technologies and platforms, such as the use of dynamic positioning systems, has emerged. Also, all of the technology associated with autonomous underwater vehicles, and especially some of the deeper capacities, has its roots in oil and gas and other industries. So here's an example of how these industries have pulled new technology. Fisheries has done the same thing. And the example I choose to cite is not one that you would tend to think of naturally. The example I tend to cite is data processing, because what we've seen in fisheries of late is that there's a need to coordinate the systems for observations, the systems for navigation, and you'll see in this particular slide some of the systems for image processing. And specifically what's become important in fisheries is the ability to monitor the fish, count them, define the species, identify the bycatch, and then process those data. So remarkably, fisheries has been driving a lot of technology in the area of artificial intelligence and machine learning in order to do this kind of signal processing. Aquaculture is another area, and for this one I choose an example from my own home state of Oregon in the United States, where the oyster hatchery business is quite prolific. And what we learned in recent years is that we've got to start building new sensors to support aquaculture. Specifically, with the unfortunate emergence of ocean acidification, we've had to develop technologies like this particular technology that monitors pH and PCO2 in order to ensure that the larval oysters are grown under the right conditions. And in fact, what we now have is real-time flow-through systems for monitoring PCO2 and pH in order to ensure the health of these particular economically important species. Commercial shipping, another traditional economy, another traditional application, has been particularly influential in developing what might be called the systems of systems. In the United States, one of these systems of systems is our physical oceanographic real-time systems, where the port pilots take advantage of all of the observations of currents, waves, wind, temperature, salinity to optimize the route into and out of these ports. And this listing shows you in the United States the roughly 20 different systems that we've got located around the country. Ecotourism is another interesting one that has pulled technology, and the technology pull here has been around the development of apps. And it turns out that for even something as seemingly simple as whale watching, there are now abundant apps, both iOS and Android, to allow you to figure out when and where you might see the whales, but even more importantly, now it allows citizen science. It allows the public who is going out on these boats or on the beach and who are counting whales to provide that information as a data service. So this sort of app development is new and unique. And of course, undersea mining, something which years ago was not considered economically viable, and now, very interestingly, we're seeing a lot more attention to deep sea mining. And what this has done is provided some impetus for development of wonderful new acoustic sensing systems like the ones shown here. Highly sophisticated multi-frequency systems that allow us to analyze the structure, the subsea structure. In this case, you're looking at methane venting from the subsea. So really some remarkable new imaging technology. Those are the traditional applications. Those are the applications that we tend to think of as the traditional blue economy. I would argue we are on the edge of development of a new blue economy, and that new blue economy is a knowledge-based economy. It is not extractive. It supports the extractive economies, and extractive economies would be fisheries, mining, oil and gas, but it's based on information, and it's based on what many people now call environmental intelligence. That is based on the observations, the data that are collected, and the emergence of ever more sophisticated and skillful models. We can provide predictions, forecasts, hindcasts, nowcasts, projections of what different phenomena may look like in the future. The challenge for us is ensuring that the providers and the end users are supported by a group of intermediaries, those third-party service providers. The concept is not dissimilar to what we have seen in the private weather industry. Now, I remember 40 or 50 years ago when companies started coming out like the Weather Channel in the United States, and I remember thinking, no, there's no way anybody's going to watch weather for 24 hours a day. Well, suffice it to say, the weather industry, the commercial weather industry right now is estimated to be worth about 10 billion US dollars with employment of approximately 10,000 people. So there are all sorts of commercial weather industries around the world. Now, I would also offer that we have an edge over the commercial weather industry. After all, the only thing they measure is pressure, temperature, and humidity. We have a lot more variables to work with. So what I'd like to do to demonstrate for you what this new pole will be from the new blue economy, I'll very quickly go through what I consider to be case studies. And these case studies represent the economic potential. There is not an economy, per se, around each of these, but I argue there could be. And without belaboring it, in order to have an economy, you have to be able to identify for each of these case studies what is the market opportunity, that is to say, what can be sold, and then what is needed, what product is needed to be produced. So, for example, in the weather industry, the market opportunity was to support tourism, and the product is enhanced targeted forecasts for a particular area. Let's walk through each of these and you'll see what I'm talking about. In the case of the Deepwater Horizon oil spill from April 2010, the biggest problem that many people saw was that we did not have baseline information of what the flora and fauna on the seafloor of the Gulf of Mexico looked like. So how in the world could we ever estimate what the natural disaster damage was? Unfortunately, the density of observations for these kinds of factors was so sparse. You see here for the whole Gulf of Mexico, probably only about 25 or 30 observational regimes, in this case looking at numbers of species, when what really is needed, and I'm going to show you an example from another area in the Gulf of Mexico, is a much, much more detailed characterization of the benthic flora and fauna. This happens to be the Florida Keys. So there is an opportunity here for some entrepreneur to come in and say, we will provide maps and charts of the natural environment as supporting information for activities, especially oil and gas activities. Let me talk about another one that's near and dear to my heart. The city of Portland in Oregon is on the Columbia River, and the major export from that area is grain, mostly wheat. The problem is shipping from Portland out into the open ocean in the Pacific takes about 12 hours. It's a tidal environment. There's a lot of rain and complicated hydrology going on. So the shippers tend to be very conservative in estimating how much grain to load onto their ships. What's needed is to be able to tell the owner of a ship like this exactly how much grain they can load in order to transport their vessel through what is a very complicated environment. You see in just this one snapshot the bathymetry in the upper left at the mouth of the Columbia River. You see a depiction of the salinity in the lower section in the center varying over time. And then you see a depiction of the surface currents in the upper right. Now try to imagine moving tens or hundreds of thousands of tons of cargo through that dynamic environment. There is an economic opportunity for developing the predictive models that will support optimizing the loadout of grain for this particular industry. Let's move over to the other side of the United States. Some 7 years ago, we had not a hurricane, but what we are calling a superstorm, which was basically a combination of a hurricane and a very severe low nor'easter, as we call it, resulting in extreme damage to cities up and down the east coast of the United States. This is a photograph of the subway system of New York City as a result of storm surge and as a result of not having adequate information about what storm surge impact will be. What we now know is that if we are very careful about how we build out coastal environments, grasslands and marshlands, we can actually mitigate the damage from major storms like this. So there is an ongoing concept around marrying things like oyster hatcheries and coastal architecture, which some people have called oyster-tecture, in order to protect major cities from storm surge and extreme flooding events. The modeling of this, the design of these kinds of concepts, where do you put them? How deep should the water be? How large should a built environment like that be? Is another extraordinary economic opportunity. The next case study is harmful algal blooms, something every coastal environment has to deal with. We are now at the point where the predictability of those blooms is pretty good. But there is no way that the public sector is going to provide detailed, geographically specific forecasts for harmful algal blooms. So if you have a small harbor, this happens to be a picture of the state of Florida, and you are operating that marina, that harbor, you would like to have a tailored, specific forecast of harmful algal blooms. There are people who can develop this, develop a market for providing that knowledge. And then the final case study is sea level rise. This is a photograph of downtown Norfolk in Virginia in the United States, where they developed a light rail system but completely neglected any understanding of what the long-term consequences of sea level rise would be in terms of flooding and inundation. As a result, they are going to have a real problem relocating this particular system. Imagine now that you've got a capability of providing targeted, isolated forecasts for sea level rise for a particular area. This shows an image of how many millions of people around the world will be affected by rising waters, rising sea levels. So these are a few of the economic opportunities that can be built out into this new blue economy. And here's the news flash. It's already happening. We see it in a few places, not many. Here are two examples. There's a fellow in Florida who's figured out how to provide forecasts for the tournament fishing community to tell them where, by virtue of the quality of his forecasts of sea surface temperature and currents, you are more apt to catch tournament size fish. The other example is one called Surfline, and I went in there last week and picked up the Tokushima Regional Surf Forecast. You too can buy this online for about $50. So these kind of tailored products are already out there, and we're starting to see the emergence of this knowledge economy. Ultimately, if the new blue economy is built out, we will actually have capabilities represented here. You could buy futures in ocean fisheries. You could buy futures in ocean energy or natural infrastructure management. That's what this new blue future is all about. What do we need to make this happen? Well, we need the observational tools and the capabilities. That's the exciting part. 10 years ago, when I was here for the conference in '04, we did not have many of these observational tools. The Argo network was not as robust as it is. The remote sensing systems were not as numerous as they are. We did not have high-frequency radar systems throughout the world measuring surface currents. We've got those observations and tools, and the models are also vastly improved. What we really need is the market analysis. Who's willing to pay how much for what products? And then somebody has to invest in this. There needs to be a capital investment. I'm encouraged that we already have some of these market analyses. This is a product of the Integrated Ocean Observing System in the United States, our contribution to the global ocean observing system, where estimates were made of the potential value of ocean observing products and services. And just simply stated, that estimated value is measured in the tens of billions of dollars. By some estimates, up to $30 to $50 billion per year of potential revenue from these products and services. So hopefully I've convinced you that there is an opportunity here, not just in the traditional economic sectors that are pulling new technology, but also in this emerging new blue economy that should pull new technological advances. Now let me shift gears and talk about the push. The things we are doing that may not have defined applications right now, but are so remarkable that they should help move the applications agenda. First is autonomy. And as we will see on the exhibit floor this week, this is an unbelievable area in terms of autonomous surface vessels, underwater vessels, hybrid vessels. The world is just abounding with new concepts in autonomous systems. Signal processing involves ideas like compressive sensing or compressed sensing, where sparse, incoherent data are translated into meaningful imagery. And that's a real processing example that you see. It's used a lot in high-end photography now. Some folks are looking at acoustic systems for using compressive sensing. Sensors is another area. Environmental DNA. So when I talk to lay audiences, I characterize environmental DNA as somewhat similar to being able to walk down a street, sample the air, and say who has been on that street in the last hour. Now imagine having that similar concept in the ocean, where by taking a sample of water, you can identify every species and possibly even how many of each species are in that water. Truly a remarkable technology. In the world of geographic information systems, there's some wonderful new developments. This is an example of what's called an EMU, an environmental maritime unit, which is basically a multivariate statistical treatment of all of the data in the ocean in a way that you can start characterizing different parts of the ocean as having unique features. This is a salty, warm, high oligotrophic area. This is a cold, high pH, eutrophic area. And now you can start identifying regions with a lot more specificity. It's a wonderful new technology. Other examples of technological push. Remote operations. This is a real training center, I believe it's in Rotterdam, where the ship driver sits in a remote facility and can drive the cargo vessel, the freighter. We are now seeing a world where we think about the Uber driverless car. That's nothing. We're seeing large freighters now with no crew at all, transporting from one port to another. Truly a remarkable technology. In the area of materials, we're seeing some fascinating materials. The organohalides, like perovskite, for example, are going to make solar cells much more efficient, much less expensive. In the middle, you see the chemical structure for an iron arsenide. And now an iron arsenide is a high-temperature superconductor. It has virtually zero electrical resistance. And on the right is a new compound called bismuth selenide. Bismuth selenide is something called a topological insulator, which means it conducts on its surface, conducts electricity on its surface, but not in the inner core of the material. I have no idea what the application of that will be in marine technology, but I've got to believe that there could be some significant advances in sensors or AUV power systems, any number of different applications. But when we talk about new technologies, let's not just limit it to the hardware, if you will, and the material. There's also interesting technological advances in other areas, and I picked this one out because it's completely different. Blockchain is the foundational platform for cryptocurrency, like Bitcoin. The fact that we have so many nations here in Kobe talking about research has implications for the finances of that research. And I wonder how much of this kind of technology will affect how we do research globally in the oceans in the future. I have no idea, but it is a very different kind of technology which didn't even exist years ago. So the whole point is that we've got to take these concepts that are pushing technology, try to find the applications, and also look at the applications and see what's pulling us in new directions. But there's an important caveat. And the caveat goes something like this. We tend to think that the knowledge and the expertise and the experience for applying marine technology and developing marine technology is within our community. That it's all of us in this audience. It's everybody that comes to oceans. It's everybody that's going to sea. It's all of the institutions represented here, academia, JAMSTEC, NOAA, all of these various institutions. And yes, those are important areas, but there are disruptors. There are people and institutions well outside of our sphere that are doing amazing things. Some of you may know this guy. He is a very, very old 22-year-old from the Netherlands named Boyan Slot. And Boyan had an idea how to clean up plastics in the ocean, and right now is spending in the neighborhood of $20 to $30 million with a prototype boom collection device off the coast of California. He is convinced that if this concept works, and oh, by the way, has built a scientific foundation around this, that we may be able to dramatically reduce the amount of plastics, not microplastics, but the macroplastics in the surface ocean. So not all of the plastics, but he came out of nowhere. In fact, he walked into my office when I was at NOAA several years ago. As you can see, he's cleaned his act up here. He was 19 years old at the time, with a t-shirt and cut-off shorts, and I thought, this can't be real. Well, it is real. He's a disruptor. These guys are disruptors. David Lang and Eric Stackpole, two young men who decided they wanted to go treasure hunting and they couldn't afford to buy an ROV, so they invented their own. And they now have an open source ROV community of people who are going out and building their own ROVs, open source code, and they're setting the traditional ROV community on edge. They had no background in our field. This guy, Joe Rizzi, an entrepreneur who lives in Hawaii, and he was very curious about trying to monitor some of the sounds that the whales around his home in Hawaii made, and he decided he needed some kind of platform, and he invented the wave glider and started the company called Liquid Robotics. I'm guessing Joe Rizzi and Eric Stackpole and David Lang and Boyan Slot have never been to an oceans conference. And yet I'm also telling you that if I asked how many people in the audience here have used ROVs, open ROV, or the wave glider, we would get a significant part of this audience indicating that. And then the other disruptor I want to bring up is XPRIZE. XPRIZE has been doing some interesting developments in mapping, in sensor development, and then they had the idea to start something called the Blue Button Competition. And the Blue Button Competition was aimed at high school students. And $100,000 was put up as a winning prize for the teams that could develop new apps using ocean data. And there are now, if you go to this website, you'll now see that there are 7 award-winning apps for doing some extraordinary things with ocean data. And this gets to the new blue economy. Again, these are not the people that we tend to think of as the hardcore innovators within our community. Now, don't get me wrong. The hardcore innovation that's going on here by all of us, by the people who participate in OES and MTS, is an amazing group of people. But there are also these folks outside of our community who are contributing. So what I'd like to do is just close by nailing down the main point. And if you think about the concept of pulling technology from applications and pushing technology from research,